Welcome to Advanced Geomatics 4301, Automation and Application Development for GIS. And we meet Mondays 2:30 to 5:20 in general, but we won't always use these times. We'll talk about that, as I mentioned, a bit later. And this is a digital hybrid course. So it means there's parts you do online, and there's also times when we meet together synchronously. And my name and my email are there if you need to contact me. I have a recommended book for the course for those of you that feel you might need a reference. This is the only good one, and this is a Python scripting for ArcGIS Pro. There's also Python scripting for ArcGIS. It's not a whole lot different, but it's different enough that as a novice developer, you will have issues if you don't use the right book. So there's two books by Paul Zandbergen. One is for ArcGIS Desktop, and the newest one here just came out in the summer is for ArcGIS Pro. And you can get that on Amazon for about $73 if you want it. We also have a book that's available to us for free, which is Python for ArcGIS. And this book is also kind of geared towards ArcGIS Desktop with examples and stuff. But the majority of the stuff in there, 95% of it, applies equally to ArcGIS Pro. So that's one that we have for free that you can read, and it's good for everything except for anything to do with network analysis or mapping. So what we call the mapping module or the network analysis module in ArcPy. So those two, anything referencing those two in that book don't apply because these are completely different in ArcGIS Pro. But you'll have time to learn about that later. You won't understand everything I'm talking about right now, and that's okay. So Python is an object-oriented programming language. It's easy to learn, so it doesn't have a lot of syntactical adornment, let's say. It's free and open source, and so everybody can use it. You can download it for free. There's all kinds of flavors of Python around. It's cross-platform as well, so Python you can run on Windows, on Mac, on Linux, and stuff like that. So it's cross-platform. It's an interpreted language, which means it's easy to write programs in and debug in real time. An interpreted language is one in which you write a statement of code and you hit enter, and that code is immediately compiled and executed so that you can see the result right away. That's different from other languages which are not interpreted, let's say the .NET language family, C#, C++, VB.NET, etc. Those ones are, you have to write a program, and then you run the program once it's completely written. You can't just write a line by line and run them interactively like you can with Python. And Python is close to the R language because of that. So R, another language for data science, and Python, a language as well for data science. Both are interpreted languages. It doesn't mean they have any less power than an interpreted language. It's just the way code is written is different. So Python is a full object-oriented language, and we'll be using Python 3.7 or something around that. Anyway, Python 3 version. As long as we're using that, we'll be fine. And the library of functions exposed by ArcGIS Pro to do things like maybe clip layers or any geoprocessing commands, etc. They're all built on what are called Arc objects. So the Python package for ArcGIS Pro is simply a API, and that means application programming interface, a means by which we can communicate and write statements. It's an API to ArcObjects that do the work in the background that you ask the Python statements to do. But you don't have to worry about that because that's invisible to us. So that's transparent. It's not something you have to deal with. Now, Python is the main integrated language inside of ArcGIS Pro and ArcGIS Desktop and all the ArcGIS products. However, within ArcGIS Pro, there are places where Python can be used throughout, so that's a bonus. But there are places where you can use other types of languages like Visual Basic Script, JScript, and Arcade, which is a language created by ESRI or Esri, specifically for things like labeling and all that type of stuff. But Python is available throughout, which is great. So we learn one consistent syntactical language, and we can apply it throughout ArcGIS Pro. So where do we find Python in ArcGIS? Many places. The field calculator, for example. So the field calculator can use expressions, right, to deal with fields like field 1 plus field 2 as an example. So field 1 plus field 2, and that can be written in Python by default. So when you calculate field, by default you use Python expressions, but you could change that to Arcade or SQL if you wanted to. So you can also use SQL statements to do computations within this newer version of ArcGIS Pro. But Python is what we're interested in because it's, again, available everywhere. So one place is the field calculator. And then, of course, in our toolbox, many of the tools that come with ArcGIS Pro that are built by ESRI or Esri International in California, these are written in Python. So here's just an example of one toolbox mapping clusters and one tool, and that's what the tool looks like. It's a Python program. Like so. And of course, I don't expect you to understand everything that it says here, but you can see that it's just a readable bunch of code. And so many of the toolbox functions in ArcGIS are built on Python. In the labeling engine as well. So when you label features, you can often use label expressions like that to do certain types of things, and you'll learn about this later on, like in lecture module 6 of the course, when we look at the .mp module of ArcPy. And you'll see how we can make label expressions and use them for labeling features, to customize that labeling. And of course, you can use Python, which is the default, but there's also, actually no, VBScript is the default, I think, for the labeling. So you have to change it to Python to use Python. So it's one place where it's not the default. And you can use Arcade or JScript. It's a JavaScript type of subset. VBScript it being a subset of Visual Basic. And of course, the most common place you're going to be seeing and using Python in ArcGIS Pro is within the Python window, which looks like this. So the Python window in ArcGIS Pro looks like that. And I'll show you where to find it. It has code autocompletion and function syntax. And that's what you can see here, the code autocompletion right there. So when we type the name of some Python object that has methods or properties with a dot, and you'll learn what these are, then it shows you the options. So it makes it easy to remember things. You don't have to remember by heart every little command function or property in Python. Here in ArcGIS Pro, I click on the Analysis tab, and you'll see History on the far left, Model Builder, Python, And if you click on the little arrow beside Python, we can open the Python window. The Python window contains the instance of Python running within ArcGIS Pro. So for example, here, I'm just going to say import ArcPy. This is not necessary inside of ArcGIS, but I'll do it anyway for good habit. It's necessary outside of ArcGIS in an IDE. And I'll say from ArcPy import env, and then I'll just say I want to check the environment workspace. And that's the current environment workspace because I just have a temporary project open right now. So that's the Python window. And I can do anything in there that I can do in any Python. 7 times 2, I can say x equals 10, for example. I can say dir x to see what all the methods and properties of that are. And it also brings up, when I do that, the information about the function in terms of its syntax and what its particular parameters mean. So dir object returns a list of strings. So I could assign that to a variable if I wanted to. I can just do that. So dir x, where x equals 10 an integer, and these are all the functions, or called methods, that belong to that value 10, which is in the variable x right now. The other place I can find, and again, you don't have to necessarily understand all the things I'm doing right now, I'm just showing you where Python is. The second place we find Python is in the Python notebook called the Jupyter notebook. I'll just close the Python window for now. So this is another place you can use Python within ArcGIS Pro to write small scripts, for example, that you're going to run, and you don't want to do it in an external IDE. Well, this is the notebook, and I can type in here things. I'll make this as a title. I'll say this is a test of Jupyter notebooks in ArcGIS. And then here, I'm going to specify that particular input is going to be heading, like so. So I'll change it to markdown, that's fine. I'll click plus to insert a new one, and this will be code. I'll do the same thing I just did. I'll say import ArcPy, and I'll say from ArcPy import env for the environment settings, the environment class. And I'll say env.workspace. And none of these have run yet. I can run them by clicking the little run this cell, or I can click run up here to run all the cells. If I run that, then it gives me my output right here. So the notebook is another place you could run Python in ArcGIS Pro. And the advantage of the notebook, well, there's a number of advantages of Jupyter notebooks you can read about online. But one advantage in the context of ArcGIS Pro is that you can do multiple lines and run them. So it's kind of like a little IDE inside of ArcGIS Pro. When I first open up PyScripter, it gives me what's called a module stub. And right now, this is for creating classes in Python. We don't need any of the stuff that's in that window. We just want a blank window whenever we start with our interpreter here. So here in our interpreter, we have a script window, which is right at the top where my mouse is. So we can write multiple lines of things, just like before, import ArcPy. And that first import is always slow, import ArcPy. And I could say, from ArcPy import env. And then I could say env.workspace. And I could run that whole thing just by clicking the run button up here. Say print env.workspace. and I'll run it. There we go. And it says none because we don't specify a workspace. Now we're outside of ArcGIS Pro. Right now, the ArcGIS Pro that is open and this window know nothing about each other, but they're both using ArcPy at the same time. So often we want to know what is the script, what's the difference between scripting and programming, and there's no difference really. Now, object-oriented programming is one in which things that you work with as part of, let's say, a software like ArcGIS Pro are built on a object model basis. For example, ArcGIS is based on Microsoft's component object model because it works with Windows, so it's based on the COM model of Windows. The component object technology is a way in which software can be exposed, functionality can be exposed of every part of the software to be manipulated by a programmer. And it works something like this. Here we have what's called a UML diagram, UML. You won't be seeing a lot of these in the course, so you needn't worry too much about them. But UML is a diagramming language for creating objects, basically. So one object in the real world, right, this is how COM works. In the real world, if we had an object, it could be called a restaurant. And if you want to know anything about the restaurant, well, you can't just go into the back part of the restaurant and go through paperwork or anything like that. Anything you want to know about the restaurant, you have to ask the manager about. The manager is the interface to the restaurant. The restaurant is a black box. In other words, we don't know the details, the layout, or anything about the restaurant, what its profits are, how much food it has to order, where to order from, or anything. If we want to know any of that information, we just ask the manager. The manager then would have certain things that we can ask called properties and certain things that we can ask the manager to do called methods. Likewise, if we go to eat in a restaurant, restaurants often have a bar and a kitchen. The kitchen is where the food is prepared and drinks are prepared at the bar. And if we want to get something on the menu, well, we don't go into the kitchen and make it ourselves. We don't even know who's working in the kitchen. It's, again, a black box. Right? If we want to get something from the kitchen, we can interface through a waiter. The waiter can then ask the kitchen to do certain things. For example, the waiter can take an order. That's an actionable thing the waiter does, and that's called a method. So waiter, so it would be something like this, iWaiter dot take order. And that would be the order that the waiter would bring to the kitchen and eventually bring back to us what we ordered without knowing anything about how the kitchen works or even how the waiter works in general with the kitchen. All that's taken care of in the background. All we have to do is ask the waiter for something. And the waiter can have a property like name. So waiters usually have name tags, and that's the property of that waiter. They could have other ones too, specific ones. Likewise, if we want to drink, the bartender interfaces with the bar. We don't make the drink ourselves. We don't know how the bar is run. We just ask the interface called the bartender, and they bring back the drink that you want. The bar, the kitchen, the restaurant are all objects. They're encapsulated, so that just means that all the functionality of the restaurant, the bar, and the kitchen are contained within those objects themselves. So if we want to produce something, some sort of recipe, we can just work with the kitchen and interface to the kitchen. We don't have to worry about how the kitchen is run. We trust that whoever created that object called kitchen thought of everything and that it's an efficient kitchen so that it's running efficiently, etc. And this is like what we call the component object model. And this is a UML diagram. That's how they're diagrammed. And we have arrows or lines saying that the bar points to the restaurant, the kitchen points to the restaurant. That just means they're a component of. So kitchen and bar component of restaurant. And the kitchen and bar can inherit the restaurant properties and methods as well. In other words, somebody can ask a waiter to do something in the kitchen, or ask about something specific about the restaurant in general, and still get an answer because they inherit from the restaurant itself. So that can be possible. Here's a simplified diagram of the geometry model of ArcGIS. So here, for example, is geometry, the main object. And everything in vector GIS is in geometry, so lines, points, polygons, volumes, etc. And you'll see how it's all broken down here. We have all kinds of different things. We have things like down here, which is a polyline, and down here a polygon. A polygon is part of a polycurve. So it's a component of a polycurve, which itself is a component of a curve, which is a component of a geometry. And geometry, curve, polycurve, and polygon all share the methods in this direction and the properties. So that if there's a property on I curve over here, you can also get that property from a polygon because it's part of a polygon. But if there, like for example here, there's a property called I area, which returns the area of a polygon. So that's one of the properties, the interfaces I should say. I area. Well, it doesn't go the other way around. If I just have a curve for some reason, I can't ask for I area because inheritance doesn't go from the bottom up, it goes from the top down. Inheritance just means that all these properties, the things you see listed on the left-hand side of the objects, are inherited or available from the lower ones in the diagram, the more complex ones. And so this is and this is a brief one of the actual diagram for geometry. The geometry object is much larger than this. This is an abbreviated one. And so there's a lot of properties and methods on these things. And not all of them are available through ArcPy and Python. So ArcPy is the package, the Python library, that allows us to work with the geometry objects. But the Python versions don't include all of that complexity. They're much simpler, as you'll see in this course. So there's that polygon again. You can see some of the interfaces like I area gives back the area. Centroid, you just ask for it and it brings back the centroid as an I point. Right there. I can query the centroid. I can query a label point. These are methods of the polygon. And it has many other properties and methods because all of these ones are also properties and methods of the polygon because the polygon inherits from that. So a complex object diagram like that. And these are used when you're creating or programming, let's say, standalone versions or tools within ArcGIS or ArcGIS Pro. And you'll see an example of that. And you have to do that in a different language than Python. So here's an example of listing polygon areas from a polygon layer. The Python version is right here. Here And again, you won't understand all this yet. So, but I'm just giving you a general idea of what's going on. It starts by getting the current document, then listing the layers, getting the first layer and the name of that layer, and then iterating over that particular layer, looking at the shape areas, the areas of each polygon, and then printing them out. So it's a 1, 2, 3, 4, 5 lines. Now, in a .NET language, like VB.NET, for example, that same procedure looks like this. It's much longer and more complex because I have to go through all of the interfaces. And there's a whole bunch of interfaces to go through before I can get access to a polygon's area. So the Python is a much higher level language interface or API to the basic components of ArcGIS compared to working with ArcObjects directly in a .NET language. The nice thing about this, because each of the objects themselves encapsulate both the functions and the properties, they work for all types of polygons. So this is a one-ring polygon, multiple ring polygon, polygon with a hole and an island. Well, the polygon object that's been built by the programmers at Esri deals with all types of polygons. There's nothing else you have to do. You don't have to know that this is this type of polygon or that type of polygon or that type of polygon, because they would all have different algorithms for calculating their area. All you have to do is ask for area, and it gives you the right area no matter what type of polygon it is. So the shape area. And that is an advantage of object-oriented languages. You don't have to create algorithms to do certain things. They're already encapsulated in the objects that you're using. Here's examples of, this is an ArcGIS desktop just to show you some examples of what you can do with .NET languages. So when you're working directly with ArcObjects, you can write programs that use standard Windows interfaces and work with things within ArcGIS at the same time to compute things that ArcGIS doesn't compute. So another one like that. Of course, there's no code showing here, it's just showing the graphical user interface. And all those are built in .NET. And so here's an example that I built for rapid site assessment of buildings. So this is all again done in .NET. It's called UrbanRat, the Urban Rapid Assessment Tool. And it is using these type of components. So it integrates desktop components in ArcGIS that use Google Street View, mobile data collection platforms that are built in Java, and integrates them all in ArcGIS so that someone can either be out in the field looking at a primary building or looking at the building in Street View, and the information that they're collecting is the same. And that's all integrated in ArcGIS. Here's an example of what you can do with ArcObjects. So this is in ArcGIS desktop in this case, using actual data, clicking on a building, bringing up that building in Street View, and then collecting data about that building in the form, and then saving it into a database. So this integrates external services, web services like Street View, and then also creating a GUI like this, a graphical user interface in standards windows and whatnot. And that's not something you could build in Python, for example, which is why I'm showing you the difference between Python and what you can do with the full Arc objects in a .NET language. So Python is used in many tools distributed in ArcBox. So any tool that has a little, I guess, a little scroll beside it as an icon, that's a Python tool. So for example, the mean center, right there, script tool, looks like this. And this is the code inside of that mean center script tool. And once you understand more about Python and ArcGIS and Python, you'll be able to read through these type of things and know what's going on. And any of these you could edit and create a copy of and customize it with your own particular aspects of what you want that particular tool to do. So custom script tools are used in Python to create ArcGIS tools in the ArcGIS toolbox way. So for example, here you might have some equation that you want to create a tool for to compute that in ArcGIS Pro. So you can write the code right there. So you write the code that will do this type of a thing. It doesn't matter what it is right now. You write the code, and then that code is associated with a custom toolbox and a script tool. And when you open it up, it looks just like any tool in ArcGIS Pro. Or in ArcGIS, I should say, desktop in this case. Just an example. We'll be doing the same thing in ArcGIS Pro. It's the same. There's not much difference between the two when doing these things. But then you fill in with current data that you have in your table of contents, and you click OK, and it runs and sends that data to the Python code to run it and send back a returned value, an answer. It could be a number, a description that comes back. It could be a new layer or a new table. Python, because it is a data science language, it has hundreds and thousands of external libraries that can do all kinds of things with external geographic services. So for example, uploading to a cloud database. So this is a cloud database called Firebase. It's owned by Google. And you'll learn how, as a developer, down here, to be able to write code to create a tool that can then upload data to a central cloud database off-site, for example, all through Python. And that's because Python, we're using a language which has a lot of development and developers. And they create things, and companies create things to work with Python because of its popularity. And we can utilize that with ArcGIS together in Python scripts to leverage and do pretty much anything you can think of that needs to be done with data, spatial data or otherwise. The advantages of Python are, as an integrated language, well, customization of ArcGIS with a mature interpreted language, meaning a language that has been around for a while and then is actually the #1 language in the world today. So it's the #1 used language in the world today is Python. So you also have the convenience then of operating and writing Python in the software that contains the data. So you don't have to worry about data input and output when you're working with Python in ArcGIS, because the data is already there. ArcGIS knows how to handle the data. You don't have to write any particular input-output scripts to input or output certain formats of data. So no format conversion. You get immediate visualization this way as well. So once you run a Python script, you can immediately see the results as a layer, table, etc. The GIS aspect of it, well, in Python itself, basic Python doesn't handle spatial data, obviously, and doesn't know anything about spatial data. But when we use libraries like ArcPy, which is what comes with ArcGIS Pro for Python, well, the ArcPy library has functions that mirror all the functions of ArcGIS Pro, such as handling spatial data, coordinate systems, on-the-fly projection, etc. So it's not stuff you don't have to deal with, again, as a programmer or developer. And of course, contemporary GIS, like ArcGIS Pro, already contains sophisticated data manipulation algorithms rolled up within or encapsulated within the component objects that they're exposing for use in Python. And this means that you're getting probably near the most optimal fast algorithms for things that ArcGIS does. And that's much easier than writing your own algorithm from scratch. That would probably be not optimal and not work as well. And of course, one of the greatest advantages of Python as the integrated scripting language for ArcGIS Pro is the ability to integrate other external libraries. SciPy, Google Maps, GeoPy, Parse. Well, Parse doesn't actually exist anymore. That was a Facebook backend database, but no longer. Firebase being an equivalent example. WalkScore, anything. So any other library that you want to use with ArcGIS Pro and integrate the functionality to produce new types of outputs or new types of analyses are possible. Disadvantages of the Python? Well, because each object has to encapsulate all of the functions and methods to work with data, it has to also work with any type of data that would come in. So for example, if you recall the polygons that we looked at a second ago, those polygons, there's a number of different types of polygons. There's the convex polygons, there's polygons with holes and islands with lakes on them, with islands on those lakes, etc. And the object for a polygon can be quite large computationally and have a lot of overhead because it has to deal with every possible case for it to work properly. And that can be slow. That can slow things down for simple processes that you might be having. So you might simply want to do, get the area of each polygon, which is simple, but it could take much longer because you're using the object called polygon in the ArcPy site package for ArcGIS Pro. And that polygon object contains all kinds of code and exceptions, and it's quite large if you look at the actual code behind it. So that can slow things down a bit. Compared to if you just wrote a simple, from scratch, a procedural, let's say in C++ or C# or VB.NET, if you just wrote a actual program that just does polygon area, only in that, it would be faster. But these days, the differences are fairly small because of our powerful computers. Another disadvantage of using, not Python necessarily, but using ArcPy particularly, is that all the functions are black boxes. Any of the functions that we use that are associated with an object called methods, these are black boxes. We don't know if it's the most optimal, and it's not always documented what the algorithm being used is because that's often of a commercial nature. This company has a algorithm that makes polygon processing faster than all other GIS programs on the market, so they're not going to put that out there and say, well, this is our algorithm, because then they don't have a competitive advantage anymore. So the internal implementation of algorithms and objects are off limits to us. We just have to trust that they're best and that they're correct. And sometimes they're not. So we can't get into those internal implementations of functions. But generally, for most things, you don't need to. And of course, there's the bigger potential when it's integrated as a language, like having a Python scripting language, is that a lot of people can misuse the language, thinking that they're getting good results when in fact all they're getting is errors or doing things wrongly. Because a lot of people think, right, that just because you run something and you get no error, that it must be good, that the results are good. And of course, if you think that way, you've already failed. You should challenge everything you do, right? So, if you write something and it works, figure out how to validate that it worked as you intended it to, rather than just assuming that it's correct. Because when you assume that it's correct every time, well, that's misuse, and that leads to errors, and that could lead to other bad things happening if somebody makes decisions based on those outputs. And of course, interpreted languages are slower than compiled languages. That's just the way it is. Any interpreted language like R or Python will be slower than compiled languages like a .NET language for anything that you do. But how slow and how fast is relative, right? It really depends on what you're doing. Most of the time, it doesn't matter for basic operations and most of the things we're going to do in this class for sure. So using Python in ArcGIS. So the Python window. For the first exercise and for any of the things in this particular lecture, you can use the Python window in ArcGIS Pro to do that. Or I would prefer that you set up the PyScripter IDE and do it through that, since that's what we'll be using most of the time to write scripts. Why? Because you can only write one line at a time in the Python window right here. So that's a one line only. And we need to write multiple lines most of the time. Or we want to write multiple lines so that we can run them all at once to see if they all work. And that's best done in an IDE like PyScripter. So we'll do these examples in PyScripter. And in the window in ArcGIS Pro, by default, it's a very small font, and you can use Control+ and Control- to increase or decrease the size of the font in the Python interpreter window in ArcGIS Pro, by the way. It's not a documented feature, but the font size is like 10, so it's very hard to see. So a Python IDE, as I mentioned, PyScripter, and if you look at the Start Here, and you've been through the Start Here portion of the course on Brightspace, you'll have already installed or have available PyScripter. Why I'm using PyScripter for the course is that it's lightweight. So the PyScripter version you don't have to install anything. You just have to have the unzipped folder anywhere you want to keep it, and you just double click on the pyscripter.exe and it opens up PyScripter. And it will remember everything you've set in it previously without installing anything. Now, the IDE itself is just called an integrated development environment. There's also Jupyter notebooks available, if you're familiar with those, right in ArcGIS Pro. And I'll show you where those are. Now, the IDE itself is just a little bit easier to do things with. It has a little window that shows you your folders, so where your data is, so your file structure, so you can get anything from there if you want. Then it has a script window where you write your actual script or program. Again, program versus script, it's the same thing. Script usually just meaning a smaller program or a program specifically that's not a standalone program. So ArcGIS Pro, for example, is a standalone program. Whereas when you create a tool in Python to work with ArcGIS, well, it's working with inside another. So you're using Python as a scripting to create a script to automate something or do something specific within an existing software. But the fundamentals are the same thing, just different ways of saying them, that's all. So scripting versus programming, it's the same thing. So we have that scripting window, and then we can run that script, and it will run and show the results here in the Python console. This Python console is just like the one you see in ArcGIS Pro. You could do line-by-line things in this console at any time you want to test particular lines of code, to debug lines of code, etc. Or you can write multiple lines and then run a selection of them or all of them. And they'll run and the results will be shown in the Python interpreter if that's where the results go. Most often with when we get into more of the some of the mapping stuff and everything, we'll see that the results actually are going to ArcGIS Pro's database or something like that, so you don't see the result in the interpreter. Now, there are a number of Python reserved words, and these are things that you don't use as Python variables. So you have to be kind of careful, you know, that especially when we're working with spatial data, in that you might say like, okay, polygon equals my poly. But polygon is a reserved word in ArcPy, so it's not something you could use as a variable name, you know, instead like x equals my poly or whatever. So you have to try and remember that, you know, think of basic names and of things, of components of ArcGIS Pro, or tool names in ArcGIS Pro. These are all reserved words that you shouldn't be using as variables. Otherwise, problems end up happening, and you have to fix everything and start over. In Python, everything is an object. So here, for example, just in a Python interpreter, I say x equals 10. And that means, well, I'm storing 10 in x. But it's not just the number. That number has with it a whole bunch of methods and properties, because it's an actual object that those methods and properties are carried with. So the value 10 you might think is, well, it's a simple number, but it's not, in fact, because if I look at the directory of x here, which is 10, an integer, well, that has all these properties and methods. And we can see that in Python. Likewise, the object x, as you saw here, which held a string, has different methods. So for example, if you look at add is the first one here, ABS is the first one here, because ABS means absolute value. So the square root of the number squared. Well, that can't happen for a string. It's a different type of data. So it has something like add here instead. So the same methods and or properties are not going to be the same for every object type. And this is what encapsulation means, that all those methods and properties are carried with the variable x up here, because it's an integer. So 10 has to carry around with it all those properties and methods. It's just part of an object. And all the methods and properties are inside that object that can be used with that object. That's called encapsulation. When I first open up PyScripter, it shows me this stuff in a blank script window. And we don't need any of this stuff right now. We'll see what all this is much later on in the course. For now, I just want my script window to be clear so I can write some lines of script. So I can say, for example, x equals 10. And if I run that, I don't see anything down here at the bottom in the actual interpreter, but now X has been assigned the value 10 in this interpreter window down here. And so if I want to look at what X is, I can just type X and I can see it. It's 10. I could also say, let's look at all the properties and methods of X that it carries along with that value of 10. So I'll say print dir X, like so, and I'll run that. And it prints them all out, and you can see them all here. So X has all of these properties and methods. All of the properties or methods that have double underscore in front of their name and then double underscore after their name are called private methods. They're not meant to be used in programming with X, although you can use them if you want to. The ones that have normal type of looking names that have no underscores are public methods or properties. These are the ones that are usable with X. So for example, if I'm up here and I type X dot, so with X dot, I'm going to see first all of the public methods. And then after the public methods, it will list all the private methods or functions that can be used on X. For example, like ABS, like so. So if I said print, not X, I don't know why it does that, print X here, and that value, I'll run that, it's going to print the value 10. If X was negative 10, and I run it again, it'll still print 10, because the absolute value method here takes whatever is in X, which is negative 10, and it squares it, and then takes the square root, giving back a positive integer instead of a negative one of the same value, like so. So that's called a private method. The public methods here are things like turning it into a real number. And that's all that does. I can check the type of X. I can say, what is the type of X? I'll run that. And it will say class int right here. And again, it's running all these other ones like dir first, but I don't need that to be run every time anymore. Just to give you an example. So type is a built-in Python function to check out what class a particular object is. So print type X, and I run. It says class int. So 10 is an integer. If I had 10.0, I run it, it'll say class float because there's decimals on that, and it automatically knows that that's a floating point number. What if I have a different thing there? It's not a number, but a letter, like hello, a quote. Something in quotes is called a string, and so it'll say type string, str, like so. And strings, of course, have, instead of type, I'll tell you dir, they have a different set of properties and methods. So you can see the string has many more public properties, doesn't it? And maybe a little fewer private methods. So for example, down, and I'll just do it down here in the actual interpreter window, just to test some of these. So I'll say X dot is upper. Is upper. False. And that's because the string hello is not all uppercase. I could do upper. I could change it to uppercase. I can say X dot upper, like so, and it will return the string all in uppercase, hello. And so this function, upper, is upper, these are all built or carried along with X now because X is a string variable. Some are public methods, which are documented. So when you use the syntax completion in ArcGIS Pro or in the interpreter, you will see properly named properties or methods. That means they don't start with a double underscore. These are called public methods. And these are the ones that are intended to be used. The public methods won't change with new versions of Python. Whereas the private methods, anything with double underscore at the end, at the beginning, these are private methods. And there's no guarantee that the private methods will not change between versions of Python. And so you're not supposed to use private methods for that reason. Now, if you're just writing something for yourself to do something and you find a private method that's useful, go ahead and use it. But if you're sharing whatever you create, let's say a toolbox with Python tools that do a specific type of analysis, well, at that point, make sure that you get rid of private methods and instead use public methods or different variable types that have the methods you need. So again, here's an example of a private method, x dot double underscore occ double underscore close braces, right? So that's an octal, and of 10 you get, for 10 you get 0, 1, 2, and that's 10, right, equals 8 squared plus 1 times 8 to the 1 plus 2 times 8 to the 0. And that gives you the octal equivalent of that number 10. Not that you need to do that for this course, but just showing you an example of using a private method. There are 4 standard data types. We have strings, lists, tuples, dictionaries, and numbers. Numbers can be double or integers, so things with decimal places and things without decimal places. Strings are anything in quotation marks. Lists are anything in square brackets where the objects, and they can be any objects that's valid in Python, are separated by commas. So they can have mixed things in them like that. 1, hello, 4, 4.5. So this is 2, an integer, a string, an integer, and a floating point number. The tuple is just like a list, but it has parentheses around it. The difference between a list and a tuple is that tuples are immutable. You can't change them. So you can't change a tuple. But you can change and modify a list. So those are modifiable. And a dictionary. So we'll look at these. Dictionaries more so at near the end of the course when we look at the use of Python and external libraries to access web resources. So in terms of numbers, we have these types. We have int, float, and complex. You needn't worry about complex for stuff we're doing. So int, anything without a decimal. Float, anything with a decimal. And Python knows what it is, so there's no explicit type declarations in Python. In other words, you don't have to say, var x, int, or whatever. Instead, you just say x equals, 10, and Python knows that that's now an integer. X is an integer, not a float, because there's no decimal. If you put a decimal there, then it becomes a float. And so Python knows how to deal with these things by its implicit type declaration. So working with numbers, some examples. So work with numbers. So for example, let's look at how numbers work. So I could say, I'll say x equals 10, like so. And I'll just run that to have x there. If I want to see what's in I go to the console, just type X, enter. It shows me the value is 10 in there. What if I do this? I say X times, which is asterisk, equals X. Now I look at X. X is 100. So this, for example, is a type of operation that says take X, multiply it by itself, and store it back in X. You'll only see this type of form in advanced programming. So advanced programmers use this type of compound unary statements together frequently. Or I could say X plus equals X. Now if I look at X, it'll be 200. This one means take X, add it to itself, and assign it back to X. So it's a weird way of doing things, isn't it? But you might see that sometimes when you are looking at other people's programs or answers on the internet. So now you know how these type of compound operators work like that. Generally though, we do basic things like I could have X, I could have Y equals 5. And I could say, Z equals X times Y. And I could say then print Z. And I can run all that. And it prints 50 down here. Right? 10 times 5 is 50. Or I could say divided by, and that would equal 2. And notice it's 2.0. I divided two integers, and whenever I do a division, it gives me back a floating point number. Why? Because most of the time, a division of X with Y, or any two numbers, will give a rational or irrational number. Let's say like 5 and 9, for example. It's 1.8 now. If I say 9.2, I do it, then I get a large rational number like that. So division always gives back a floating point number. And I could check that. I can say, okay, I'll just go back down here. I'll say type X right now, and it's a float. Or I should say Z, type Z. That's the one, that's the result, float. And of course, you can add things together. It doesn't have to be division. It could be, X plus Y minus X. And that'll just give us back 5. Like so. So you can make any equations you want. You can write them out arithmetically. And that's how it works with numbers. Numbers are pretty straightforward. Arithmetic operators work with numbers. But also inequalities. So I could say print X less than Y, and it will say false. Because X is 9.2, Y is 5, so it's natural that X is not less than Y in that case. And with that, we get a false. Likewise, as I say, equals, X equals Y, that'll be false. I'll get rid of the other print statement. And Z for now. False. If X is greater than Y, well, that's true. Like so. String data type. So strings in Python are any set of characters, even if they're numbers themselves, that are found within either single quotes or double quotes. Strings can be sliced. So slicing uses the slice operator, which is the colon right here, inside of square brackets. String indexes start at 0. So for example, that's 0. That's index 1, index 2, index 3 for the space, index 4. So 0, 1, 2, 3, 4, all the way to the end of the string. So for example, let's try that, some of these slicings in Python. And you'll notice that we have two ways to concatenate strings. So concatenate just means put together. So concatenate strings. One is to add strings together with the plus sign. The second way is to use a format statement of a string. So format is a method of any string object. So for example, here I have quote, curly brace, space, curly brace, quote, end quote. And then I say dot format, and whatever a string is will go into the first brace, and whatever I write here, comma, for my second input will go here. It just says that this particular string expects two inputs to be replaced in the string wherever these curly braces are. And the first one goes by order. So format a string. So a string, which is GEG4301 Advanced Geomatics. And then space, and then I said put rules, another string here. So two ways to get the same thing in the last two there. And you should generally always use the format method of a string to do concatenation 90% of the time. So working with strings, we can look at lengths. We can split strings, which are very useful. Look for occurrences within a string of a particular letter or number. Find the first instance of something. Change the case, or even replace things within a string with other characters or sets of characters. And you might think, well, why are we doing all this stuff with strings? Well, these type of things are fundamentally important when you're working with data, especially external data that may not be coming from ArcGIS, but let's say from a text file of some sort. So in reading in text files, parsing strings and stuff is very important. And so good string skills are very useful in that respect. What about a string? Say x equals GEG4301 Advanced Geomatics, as an example here. So I have a string now. Well, I can do things like get the length of the string. Print len, that's the built-in function for length, x. So how many characters are there? 26. So that contains 26 characters, excluding, of course, the quotation marks. They don't count. That just qualifies the string as a string. What about other types of string functions? Well, strings are sliceable. In other words, G is at index position 0, E is at 1, G is at index 2. So let's say I want to get, I'll say print X all the way up to 3. What do you think it'll print? And I'll get rid of the length one for now. So what do you think it will print when I do that? JEG, right? Because what this means is go from the beginning of the string to the third index value, which is, in this case, 2, right? So 0 is G, 1 is E, index 2 is G. That's 3 index values. Because all indexes for things in Python start at 0. What if I say, let's say 7? Then it says GEG4301. What about the other way? What if I say I want 5, comma, or 7, comma, like that? Well, it means start at 7 and go all the way to the end. Advanced Geomatics. So that's what it gives me, that part of the string. If I have nothing in there but the colon, it gives me the whole string. Or I could split the string. I could say x dot split, and I'll say in parentheses here what to split by. Sep equals a space, like so. And if I run that, it gives me back a list with GEG4301, and then a comma, advanced, comma, geomatics. So it split up this string at the spaces, which I asked it to do. I could say, okay, let's do it at the A's instead. What would it look like? Like so. And notice those aren't included in the result, so the separator you use. So again, back to the space, and it makes more sense, GEG4301 Advanced Geomatics. And instead of printing that, I could save that in another variable called y, let's say. Y equals x split. And I can say y 0, because it's what's called a list now. So if I run those, I have to say print this, of course, to see it. Print that one. I run it again. Oh, not print E, but just print. There we go. Oh, no, I don't want that. Just 0. Y 0. There we go. Finally. So 4301. Because remember, when we split it, we have then a list with 3 components, 0, 1, and 2. And the 0th component was 4301 JEG. If I say I want the second component, index 1, I run it, advanced, and the third component, geomatics. The third component, geomatics, like so. So you can do a lot with strings. We can find certain things in strings. So I could say x.find the location or index value of the first empty space. I'll say print this so we can see it. Seven. So 0, 1, 2, 3, 4, 5, 6, 7. So that's the first occurrence of a space with the find. I could say, maybe I want to replace that. X.replace, again, a built-in function of strings. I want to replace the empty space with a space dash space like that. Now, if I run it, I get GEG4301 dash advanced dash geomatics. So wherever there was a space, it put a dash. Or maybe I don't want a dash, I just want commas between them. I want to make a string separated by commas. Well, I can run it. And then I get 4301 comma advanced comma geomatics. So working with strings, and these are just some of the functions with strings, is really important because often you're going to be working with data that is not inside of the GIS, but it comes from a text file, for example, that has to be parsed, that is broken up into individual components that can be mapped. So here's again an example of formatting a string. So here I'm saying here I have 1, 2, 3 numbers, 10, 2, 3, and I want to write a statement out that says the number string n1, 10, divided by string n2, so 2 would be put here, plus is string 3, right here, and 3. Not necessarily that this makes any sense, obviously, but just showing you an example of concatenating a string with a plus. And that's when you see it like this, it's so choppy, right? It looks very choppy. So it's a choppy way to put a string together because, it's easy to forget a plus or something else in there. The other thing, if you use the plus signs to concatenate strings, and you have numeric types, you have to turn them into numbers for them to be properly concatenated as a string. So that's very choppy. It's difficult to put sentences together that way. So instead, the format method, much cleaner. So my string, the number, here it says 0, 1, and 2. These are the index values in the format arguments right here. So 0 is N1, 1 is N2, and 2 is N3. So it just puts them in there, in that order. However, we don't need to put the index values like that. We can just have this version here, and it knows then that it puts them in the order in which you put them in the format statement. So N1 will go here, N2 will go here as the second one, and N3 will go in there, whatever N3 is. And we don't have to do any conversion of numbers to strings or anything like that when we do this type of a statement. So that's why the format statement is quite useful. And I would expect to see you using that unless there's some reason you can't use that for putting strings together. The one advantage of the index, using indexes, is that you could then switch around things. So I could, for example, say, oh, I meant that the value 2 should go here and 0 should go over here. And I could do that and not have to change the order of the values in the format statement. So now the second one, which is really this one here, the third, right, will go there, and this one will go here. So that's one advantage of using index values in the format statement, but most people don't use them and just rely on the order in which things are going in. Another thing to know about strings is how to use strings to form error messages or other sentences that you might want to tell the user about, or even yourself, during the execution of a program. So let's just take a couple strings here. I'll make the first string here, I'll call it A, excuse me, and I'll say A equals GEG4301. I'll make B equal to advanced, C equal to Geomatics, like so. So if I run that, well, I can go in my console and check out the values of A, it's 4301, B, advanced, C is Geomatics. And if I want to put them together into a single sentence, I can concatenate them like this. I can say D equals A plus B plus C, like so. And I'll just say print D. When I run that, it puts them all together, A, B, and C. But it doesn't know that they should have a space between, 4301 and advanced, and a space between advanced and Geomatics. So you'd have to put those in. You say plus, and then empty string, space, plus, again, a plus here, empty string, space, plus C. So now when I run it, it looks like something readable, advanced 4301 advanced Geomatics. What if but you see here that the issue is, already it's getting complex. I have to put A plus an empty space plus B plus empty space plus C. It's not a really great way of doing things, especially if you have to start to put things in there like numbers. Like maybe I'll have here, I'll just call it X equals 21 for enrollment. And I'll say, I want to say, okay, now here plus quotation space enrollment equals, and then I have to put plus X for 21. And then I'll print D. So let's have a look at that and see what happens. Oh, wait, there's no space after the equal. So let's have a space and then 21. Let's see what happens. We get an error called a type error. When you get an error, always read it. Particularly the last line or 2 lines of the error tell you the most information. So this is a type error, and it says can only concatenate strings, not int, toString, like so. So when we have a integer here at the end of the phrase, it can't do it. We have to first manually convert it to a string. So we say strx. Now if I run it, I won't get an error. And I'll say GEG4301 Advanced Geomatics enrollment equals 21. But putting that string together was quite difficult, wasn't it? You know, to remember all these different spaces and pluses, and the fact that any numbers you want to include in your message have to be converted to a string if they're numbers. Because the message or the concatenation operator of plus for strings only allows strings to be put together. So a better way to do this would be just to say D equals a string. And I'm going to put in here squiggly brace, space, squiggly brace, space, squiggly brace, enrollment equals squiggly brace, like so. And I say dot format. And now what I do is I put in my variables, A, B, C, and X in that order, so that A goes first in the first squiggly brace. The second squiggly brace will get B. The third one will get C. And the last one will get X. So I'll say A, comma, B, comma, C, comma, X, like so. And I'll just comment out the previous one. Not that I need to, but just so it's not being run. And then I'll run this like so, and it gives me the same result. And that's called the format method of a string. So any string that you want to print out, you can write whatever you want in there, and any place that a squiggly brace is, you just need to use a variable to put into that squiggly brace. And that variable that you're putting in doesn't need to be a string. As you can see here, X is a number. And it didn't complain saying that number can't be put into that string or anything. It just went ahead and did it. So you can have other sentence, you know, let's just say D instead of equals here. What about I love 1 space 2 space 3 dot format, and I just want A, B, and C. So it prints out I love 4301 Advanced Geomatics. It knows to put A in the first squiggly brace, to put B in the second, and C in the third. And so you can easily make complex strings using the format statement much better than using the concatenation operator, the plus sign on strings. Another fundamentally important data type, especially when working with ArcPy and ArcGIS Pro stuff, is lists. And lists are heterogeneous collections of objects. They can be homogeneous collections, like you could just have, for example, a list with 1, 2, 3, 4, 5, 6, 7, or you could have a list like we see here, a heterogeneous list with 1, which is a number, int, string, float, string, int. So we have 3 different data types in that list, and that's fine. Lists are okay with that. Now, most of the time, you will be using homogeneous lists, but they don't have to be. So let's see how we can look at a list in Python. Next up, we have lists of objects. So for example, a list could be just a set of numbers. So I could say X equals a list of numbers, and I start a list by creating my open and close square brackets. And I can say 1, 4, 2, 5, 2, 6, 7, 3, 7. And if I run that, it sends it to the console and I can look at it, X, and it shows me that that's a list. I can say type X and it will say class list. So the first thing we can do with list is to slice lists. So let's say that I want a particular range of numbers in there. Let's say I want just the last number. So I can say X, comma, -1, like that. I should say colon -1. So if I run that, I should print this out. I'll say print X, like so. Then I'll run it. So it prints, in this case, everything up to the last item in the list. And that's also slicing or subsetting the list because you want to get rid of 7, let's say. Likewise, with a -1 up here, and I run it at the beginning, then I just get, interestingly, the last item. Why? Because it says basically -1, so n-1 to the end. So n-1 to the end is 7. So I can get the end of the list. And of course, to get the start of the list, I would just put 0 and no colon in there at all to get that part of the list, because the value 1 right here. But you'll also notice the difference in the return, right? When I use -1 in there, like so, then I get 7. If I use -1 colon, I get a list returned. See the difference? What is returned with a -1 colon is a list. With just -1, because this is a one-dimensional thing, it returns the n-1 as a non-list object, but as an integer in this case. If I want items, let's say from the 4th to the 5th item, I would put here 4, 5, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. So I should get 5 and 2, right? What, I just get 2? What's going on here? So that's strange. That's not even in what I thought was the 4th one, because I said I wanted 4 to 5. And the 4th and 5th here, items, are starting at 0, 1, 2, 3, 4, and 5, 2 and 6. And that's because I'd have to go 4 to 6 to get those two. Why? Because it starts counting at 0. So 0, 1, 2, 3, 4, 5, 6 is right there. And it will give me 4 to less than 6, which would be just then 2 and 6 coming out. And it returns that as a list, another list. So you can slice and dice lists very easily with these square brackets. I can also do other things. Let's have a look at dir of list to look at the properties of the list and the methods that are available. And I'll have to print that. So I print X, but dir of X, like so. No, not the extra X there. There we go. So I'll print that. And these are all of the different built-in or encapsulated methods. So there's a lot of private methods like add. So adding two lists together. Size of. Some of them I don't know what they are. And then we get down to the public methods down here. append, clear, copy, count, extend, index, insert. So if I want to look at some of these or try some of these out, I'll just print the results. I can say x.index. And what am I looking for? Well, let's look for the value 2. We'll print that out. And it says 2. So 0, 1, 2 is the first occurrence of the value 2 in the list. That's how index works. If I said index 7 and I run it, I get 6. So 0, 1, 2, 3, 4, 5, 6 is the first 7. So it's a base 0 index value that you get. What if I want to insert? So I say insert an object. Let's say the object is going to be the value 99 before which index? Let's say before 3. There we go. So here, there are a number of functions or properties of objects where the method itself works and modifies the actual object so that you don't have to assign that object to a new variable like we were doing with a y here for using insert. And in this case here, x insert 399 inserts the 99 after the third value, which was 2, and the list itself, x, is now modified in memory. So it's actually a permanently modified thing. Other types of properties for lists we can have, you can just click on there, there's append. So if I want to append, I just need to say what object I want to append to the end of the list. So let's say I want to append the number 98. And I run that. And here, what it did was replace the last value it replaced the last, it added to the last value. So I reran the whole thing. So x has 1, 4, all the way to 7. And then when I append 98, 98 goes at the end. And so the list has had something appended to it. I could append any object there. I could append a string if I want. If I do that, then it appends hello. Now I have a mixed object or list object. And that's okay for lists. Lists can contain a mix of different object types. And that way you can create your own data structures and stuff just out of basic lists like that. Well, let's just try remove. Remove the value hello. Now check out x. There we go. So it's gone now. So we insert it in hello and then we removed hello by name. That's one way to do it. Pop is also another way where you can pop out something at a particular index from a list. Fine, I'll try it down here again, x.pop. Okay, so there, x.pop 4. Now it brought 4 out of the list. And you see the list now has no longer has 4 in it at all. We also have for lists, let's go back up here, x.extend. So to extend the list, I must send it a list to extend. If that could just be one number like so. Extend, but it has to be in the, it's just getting a bit of a keyboard lag here. Uh-oh. There we go. So we need to put a list in there, like so, of something, like let's say 34. So now if we check out x, it appends 34 here. If we had done it this way, let's say without extending it with a new list and just had 34 in here, then we get a error because 34 is not an iterable thing. So it either has to be a list of things, and it could be multiple things in there, or a tuple, or a single number, but it has to be in a list. So doing that now, then we check out x here. It's much longer, so it has a whole bunch more numbers in there. So lists are very common, and so you should practice all the examples that are in the slides and in the exercise itself. So doing things with lists, fundamental skill for Python. So like with lists, as you saw, we can extract portions of a list or particular indexes and their objects in a list by slicing them. So this using the slice operator, which is just the open and closed square brackets, and then an index value. And again, indexing always starts at 0. 1, 2, 3, 4. So the fourth index in here is the fifth object. So you just have to remember that. In Python, all indexes start at 0. Let's do some more work with lists for the number of occurrences of a value in a list, which could be interesting. So how many times does the value 2 occur in a particular list? We can add items to the end of the list by appending them. We can extend a list by using the extend method and giving another list in there, and that will extend the list with two more index values. We can get the index of a value in the list. So if you're looking for a particular value in a list, whether it be numeric or whether it be a character, you can search for it, saying list.index and then value. Likewise, we can remove elements from a list by name. Functions are the backbone of doing computations in Python with ArcGIS or any other things. They basically are the language. So functions take in something and they act on that something. That something is called the argument. So that could be a number, it could be a layer, it could be a data path, etc. And then they do something with that and output a return value. Now there's many built-in functions in Python. So for example, in the math library, we have a whole bunch of built-in functions, and they're called methods because you say math dot, for example, cos for the cosine, and then you give it a number, and it returns the cosine of that number. If you import math, all the functions in math, then all the functions in math become functions rather than methods. So it really depends. The names are interchangeable, function versus method, when we talk about Python a lot of the time. And when we use a function, it means we're calling the function. And these are just some examples on the right of built-in functions. So for example, isNaN. So, isNaN, and then with parentheses, some value, and it will tell you true or false if it's a number or not. So as I said, in functions, they have two things in the function. Functions internally have parameters. So here is the syntax for the function sum. Sum takes in a sequence So any sequence or iterable that contains numbers, obviously. If it was text, we can't say what's the sum of the text, for example, because it doesn't make sense. So it must be a sequence of numbers or an iterable of numbers. And here, the word sequence is the parameter of that function sum. We usually don't look at the parameter itself or even use its name most of the time. We just send an argument to that parameter. So sum and then of x, where x is this list of values or tuple of values up there. And so it acts on the argument and takes the sum of the values in the argument, returning that sum. And of course, you could save it into a variable if you wanted to. Most of the time, you would be doing so when using functions. So functions take in arguments. The arguments are passed to the function parameters. So x becomes the sequence, and then inside the function itself, again, it's a black box. Sequence is a name that's used in there in order to add up values and things like that. So using functions, so here's some basic built-in functions of ArcGIS. Not ArcGIS, but I should say Python. So we'll try some of those. And methods. Methods are defined on objects. So any object has methods. Methods are functions, basically, that are encapsulated with the object. So the syntax is object.method, and then any arguments to the method here. Some methods have arguments, some have no arguments, and they're still methods, meaning a function that operates on the object. Properties, on the other hand, have no parentheses. So object.property is also a possibility. And they wouldn't have any parentheses for properties. So object.method. So here, for example, we see x is a string. And if I look at the dir, or the directory of x, which is the object, which is a string, again, it shows me all of the private and public functions. Again, public functions don't start with a double underscore. So for example, there's many here we could try. We'll try a couple of the methods here for strings. Here, like the other methods, the find method, find the index value where the first y occurs in this string. And that would be at index 1. So x.find y would return the value of 1. Here, GIS is fun. And let's say we want to replace part the GIS is fun with something there. Well, x equals GIS is fun. And we see x.replace GIS, this part, with this. And that, again, is using that method replace that comes with the string itself. So it's called a method, even though it's a function, basically, of that object. Or we can change the case, x.title. So it puts it in title case instead of mixed case. Other types of functions that we can use that exist within the base R, or I should not base R, but the base Python, have to do with, manipulating iterable objects. So an iterable, as I said, is anything that is a list or tuple. So x, for example, equals, I'll make this into a list, just some numbers here. so. So we'll just check that out. So I have that list. I'll run it, and I'll just have a look what's in it. So I successfully created a list. Now there's many functions that work on a list. Let's say like sum. So sum x, because x is an iterable or list. I can save that in a variable called s. Keeps jumping around there. S equals, no, I didn't want to go up there. I should do my variables first from now on. Equals sum of x. And let's have a print s, like so. So we run that, and the sum is 128. Other things, I could say j equals x, or I could get the length of x. So I'll say j equals len of x, like so. I'll print that as well. J. And it says 9. So the length of x is 9. So it's a number of things that are within x. So to create a mean, for example, an average, let's call it AVG, equals, right? I can say sum of x divided by length of x. And then print AVG. Like so. So the average of that set of numbers is 14.22222222. So an irrational number that goes on forever there. I can get the minimum, maximum. So for example, M for minimum, or M min val, like that, equals min of x. Print min. Min val. And it is 2 is the minimum. Do the same for the maximum. I can say, okay, let's do the minimum. Now we'll do the maximum. Max val equals max of the list x. And then I print, again, max val, like so. So 2 is the lowest and 90 is the highest. I can sort the list. I can say sorted list equals sorted x. Print sorted list, like so. So there it's sorted now, 2, 3, 4, 4, 4, 6, 7, 8, and 90. Some of these are also methods. So for example, just on x itself, if I say, I'll do it down here in the console as an example, x dot, right? You can see there's a bunch of things like the count. That's how many things, parentheses. Oh, that's a count 2. Remember, that does that. X dot append, we saw copy, count, extend, index, we've seen, pop, insert. The other interesting ones here, remove, reverse. So that reverses the order of things. So x dot reverse. So now it goes from largest to smallest. X dot sort. X now goes from smallest to largest. So reverse and sort are there. And these are useful in constructing various functions that work with lists. So they're good practice because these are kind of the main ones that you tend to use a lot. Working with paths is something you're going to have to do a lot of in this course. So what is a path? Well, a path is something or a location on your computer's hard drive or hard drives. So for example, if you look at my Windows Explorer here, I'm in C temp, and there's a shapefile. So the path to that would be C temp and then the name of the particular layer. So C temp and then LM 500 meters fastfood.shp. That's the path to this particular file. And many functions in ArcGIS Python, ArcPy, require that you find the path to somewhere. So you have to send it, if you're going to do something with this layer, you can send that path as the layer argument to a function that would operate on that layer. And notice here, I have C, and these are 4 slashes. So 4 slashes are valid paths in ArcGIS Pro. And there are other ways to represent the paths, and you can see page 49 of Tateo-san's book for that. But basically, you can have double backslashes separating things as well. Or single backslash separating something, and then you have to put a little R in front of the quotes. And that means that the program will recognize this as a regular path. Because in Windows, a single backslash character like this is considered an escape character. So it's called an escape character. And it just means to the Windows operating system that whatever comes after that, like /A, for example, it means to take this as a literal string. And so if you have a path with a bunch of single backslashes like that, you have to put a little R in front of it. So R, quote, path with backslashes, end quote. And that will tell Python that this is a string literal to not interpret, in other words, not interpret the backslashes as escape characters. So paths can be a little bit tricky, and so it's very good to know them. Most of the time we'll be using paths just that have that form. But there's easy ways to get paths to things in ArcGIS Pro. You can find something in Catalog and just drag it into the Python window, and it will show you the path to it, which you can then copy and paste into your script. So working with what we call packages and modules. So in Python, strictly speaking, a module is a single file of Python definitions and statements and functions, and it can be imported and used in Python. And the file name of the module has the suffix .py, so it's just a py file, but it's just a text file called .py for Python. And you can have many functions in a module and use them in your custom development. So for example, module name. And there are many modules used in Python. We import them. So for example, built-in ones like math and things like that. Math, sys for system, anything to do with manipulating. So the system module or package is used for manipulating paths. So it has all kinds of functions in it or methods for working with paths, which are very useful. For example, if you want to get the name of all the layers or files in a certain particular folder, you can use the system walk to walk through the folder to find things and return lists or iterate through each item in a folder to process it in some way. So sys is a very common one. We'll see some use of that. And then math, of course, having all the math functions. Another common one. And notice we just import them when we need them. So import sys means expose the sys package or module and all of its functions and methods to use within the script that I'm writing. And the majority of the functionality of Python comes from these things. So once imported, you use the module, particularly its functions or methods, by saying, okay, sys.this. So if you import sys, import math, you say sys.getSizeOf. That's a method of sys or function of within the sys module. Ceil for ceiling is a function of the math. So as long as they're imported, you can then prefix the function name. So you have object method in this case, or in this case module or function, or package function. You can also import, you can say import, you can say from sys import all. And then you don't have to put sys in front of anything. You can just say get size of, for example, to get the size of a feature class in bytes if you import all the things. Now, the problem with importing all is that you could have namespace conflicts in that within two packages, there might be something with the same function name. And if they're both imported all, one will overwrite the other and you won't get the results you expect. So generally, it's best to import just the module or package and then prefix any of the functions with the name of the package. And you can shorten it like import sys as just s, for example, the letter s. So you just have to type s.getSizeOf instead of sys, so we can save some typing. So there's multiple ways to import and use the functions within packages and modules. Packages, or Python libraries, they should always be imported at the top of the script. So let's say, for example, here, I want to work with math functions. Then I would say import math up there, like so. I can have a look at those, and I'll just do it in the window down here. I'll just expand that a bit to look at some of the math functions. So I can say dir math, just so it prints in here. And you can see all the different math functions available, like logs, to take logarithms of things. Pi is a constant. Let's have a look at, let's print out math.pi, see how many decimal places it has. Pow, radians, to convert degrees to radians. Trigonometric functions. So your basic, some very basic functions like factorial, for example, more trigonomic, and degrees to get degrees from radians, ceiling, and things like that. So those are all available. I would need a numeric number or variable to do anything with that. So for example, I can't do that, any of those functions on a list. If I had a list, let's call x equals, and then I have a bunch of numbers in it, 2 and 4, for example. I can't do something like math.sign x. Why? Because the math functions only work on one number at a time. So the error here says must be a real number, not a list. And I'm trying to put a list to a math function. Most of the math functions can't work with a list. What if I just did that with a list with one thing in it? I still get the same issue, that I'm trying to put a list and not a real number. X must be a real number. And then it runs fine. If we want to see the value, of course, we could save it and print it. Y equals math.sine print y. So there's the sine of 4.52. What about pi? Math.pi. So it goes down to this many decimal places. So that's interesting. Now we have math.sine, we have math.pow. Pow takes in a base number like x and raises it to some power like 2. So 4.52 squared is equal to that. 4.52 to the power of 4 would be a bigger number, etc. So that's the pow function. You can also do this instead of the pow function. I could just say x for double squared. That does the same thing for squared. You could do this. There's raised to the power of 3 now. Raise to the power of 30 if we want. It'll just give a big number there. That's a big number. So math.pow can do this, or you can just use the double asterisks to say to the power of math dot. You can see all the different functions available here. Factorial x. We'll just see what happens. It only accepts integer values. That should say integer, not integral. So 4, for example, factorial is 24. What about 5 factorial? Well, it can't be that much bigger, is it? 120. What about 6 factorial? 720. What about 10 factorial? Whoa, that's pretty big. 20 factorial? That's a very big number. There are many math functions. Try the ones on the slides and even try some of the other ones. Get familiar with what you see there by just perusing it so that you can remember at some point, oh yeah, I saw that function or that method in that library that I need to use now. And of course, working with packages and modules is what we'll be doing a lot of, mostly in this course. In the ArcGIS functionality is organized in a package called ArcPy. So the entire ArcGIS system toolbox and parts of its user interface are all accessible through ArcPy. So it's something we have to import at the beginning of each of our scripts that we write. We'll always have an import ArcPy statement. And ArcPy has lots of functions. You can see them here. This is the dir for ArcPy. It has lots of methods, functions, and sub-packages. For example, ArcPy conversion is one of these. Right there, conversion. So that's the conversion toolbox. ArcPy.conversion means import the functions in the conversion toolbox. And there are then things like ASCII to raster. To take an ASCII file, that's a text file, that's in a particular format, and convert it to an ArcGIS Pro raster. Or features to JSON, to JSON. To convert features in a vector to a JSON representation. That's almost like a type of HTML representation. And we'll see more about JSON later on in the course when we look at using external packages. Modules that are common. We have analysis. ArcPy, of course, being the big one. But you can just, if you don't want ArcPy, anything in ArcPy itself, you could just say, from ArcPy.analysis, import something. Conversion, data access, environment, management toolbox, the mapping toolbox for controlling, maps and layers and things like that, moving them around, etc. OS for operating system tools, spatial analyst for SA, SYS for system tools, time, and toolbox tools. So these are some of the modules of ArcPy that are regularly used. So, and again, many of these are imported because it's all ArcPy. None of them should have conflicts with the names of functions. In other words, there shouldn't be, let's say, a function called clip in both the spatial analyst toolset and in the analysis toolset. So most of the time when working with ArcGIS functions through ArcPy, we just import all of the ones from a particular toolbox. ArcPy.analysis import all. Or if you don't want to do that, you can always just type ArcPy.analysis.name of tool in order to use it without importing the library. You just say from ArcPy import analysis. Controlling workflow is based on conditional statement use in Python. So conditional statements use relational operators that evaluate to true or false. So for example, equivalence, not equal to. This one, which doesn't work for certain things in Python 3. So just ignore that one for now. This will be the not equals to up here. Greater than, less than, greater than equal to, less than equal to. So these are relational operators. And with those, you create the conditional statements. For example, in a raster, if you had a raster variable, right, and you've seen this in the third year many times, raster less than 1500 would return a new raster with true or with ones and zeros. A Boolean raster, so ones and zeros, ones where the raster is less than 1500 and zeros everywhere else. And we can also use these in the context of controlling code operations or code execution as well. So for example, x equals 6, we can say if x, notice the double equals here, because that's the relational operator, is double equals for equivalence, called logical equals, whereas here this is called the assignment operator. Strictly speaking, x equals 6 means assign 6 to the variable x. And the equals for equivalence is double equals. So assign 6 to x. If x equals 6, then print x is squiggly brace dot format x. And of course this prints out 6. This x is 6. And you can see here then how, based on the value of x, statements in that part of the block here, with the print statement and any other ones that might be there, they're only run if that equivalence is true. And so that's called flow control in programming. If we had x equals 5, and then we say if x, or I should say, assign 5 to x, and then we test if x equals 6. If so, it prints x is 6. And then we have otherwise, else. So if, and then else, print x is not equal to 6, which is true. So it's just a logical set of statements here. So that's called an if, then, else block. The then we don't see. The colon here means then. In some languages, you actually type then. But in Python, you just say if x equals 6, colon, and you read colon as then. Do this. Otherwise, else, then do this. Flow control statements, such as if-then statements, allow you to run code when certain conditions are met. For example, I'll just start with an example here. I'll make a variable called x equals 5. And I want to run a statement that prints a string if the value of x is greater than 5. So I would say if x is greater than 5, then print x is greater than 5. And actually here we'll use our strings, and I'll say to x, I'll put the value in there itself dot format x, like so. So the way it works is this is the block, the if then part of the statement. So if x is greater than 5, then the colon here just means then print this. So if this statement is true, where whatever x is and it's greater than 5, it will print this. Otherwise, nothing will be printed. So if I run this, you can see nothing is printed. If I say x equals 6 up here, and I run it, it prints 6 is greater than 5, which is true. If I have 4, it doesn't print anything. And nothing is printed out to say anything. So maybe I want to have something as well that when it's not true that x is greater than 5, it will tell you, give you some information. So I do that with an else. So I go down here and I say else, like so, print squiggly brace is less than 5. Dot format x, like so. So now if x is equal to 4 and I run it, it says 4 is less than 5. So as you can see here, depending on the value of x, either the code in the first indented block is run, and if x is greater than 5 is not true, the code in the second block is run. And so this is how you can automatically have code running based on the value of some variable with an if-then statement. Loop structures are used a lot in Python. So looping simply means going over items in an iterable. Iterable things are lists, for example, most of the time is a list. So here, for example, I say for itvar, that's the iterator variable, in range 10, print itvar. So we have an iterator variable after the for, and then we have an iterable called range 10. Range is a built-in function of Python that just creates a list of 10 numbers starting at 0. So it goes 0 to 9. So that's a list to iterate over each item, 0, 1, 2, 3, 4, 5, all the way to 9. And then the iterator variable, itvar. So every time what happens is when we go in this list, range 0 to 9 is the actual list that we see here. So 0, 1, 2, 3, 9. So itvar takes on that value, 0. So the first time it prints 0. So the output of this would be 0. And then it goes back up here again. As long as there's things still in this list, it then says, okay, what's the next one? Well, the next one is in that list is 1. So it assigns 1 to the iterator variable, itvar, also called loop variable. So the iterator or loop variable, and then the next output is 1. So it's printing it. And then next time through, it's going to be 2. So it prints a 2 here, all the way up to 9. And when 9, that's the last one, then it just starts and will start to execute things after the loop. Any statements that might be down here. So looping is important. So we'll do a couple examples of that. Here is another example of looping over a list of objects. And it says for each object, that's the iterator variable. And by the way, that is anything you want. I just made that up. You make up the iterator variable. I often call it the iterand, but it's not a real word. You make up the iterator variable. Name. Not mem, but name. Like so. So since a list contains a bunch of objects, I just said for each object in the list called X, and then I just print each object. And it prints them out sequentially like that. I could have just said for the most common iterator variable is called I, just the letter I. So the most common iterator variable would just be I. For I in X, print I. But it's better to be explicit as to what that might be. For example, in many of the times that could be a row in a table. So we'd want to say for each row in X, and then print row something from the row, or row something from the row times another number, or to sum all the values in the row, in all rows, or something like that. A second type of flow control statement are loops, or what we call for loops, which are used very commonly. And a for loop can iterate over any iterable thing in Python, such as a list. So let's say I have a variable X, and I make a list, and I just put some numbers in there, like so. And I can then iterate over those. I can say for num in X, do the following. Print num, like so. So X is a list of objects. These objects are all integers in this case. And then I say for each num, which is the iterator variable, that is for each number in X, print out the numbers. So when I run this, I'll have a printout of one number per line, like so, as you can see in the console down here. And you could have often multiple things happening in a block of code like that. I could have, for example, instead of just printing, I could do something with the number. I could say, I could have another variable in here. Let's say Z equals num times 20. And I could then run it, and that will all be run. And I want to print Z there. There we go. And then I get each value multiplied by 20. Or I could have something more interesting. Let's say I wanted to scale these variables so that instead of 3, 4, 2, 4, 5, 5, I want to scale them such that they range between 0 and 1. And to do that, I have to take each value, subtract the minimum value from that, divided by the minimum minus the maximum. So I'll say here in my Z equals, I'll say X dot min. So if you recall X being a list, I'll use the function instead. I'll say min of X, and I'll say X minus the min of X divided by that got a little bit messed up there. So I'll go back to my Z, and I'll make two sets of parentheses, parentheses divided by parentheses. In the first parentheses, I'll say x, or num, I should say, num minus the min of x, which is the minimum value in x, which is the list, divided by the max minus the min. So I'll say max of x minus the min of x, like so. Then I'll print out z, and we'll see out of those numbers, there should be 1, 0 and 1, 1, like so. So here's a 0, and then 1s. So what it's done is scale or rescale x and each value in x into a set of numbers that range between 0 and 1 instead. It's called just standardizing the data. And I did that all in the for loop. Now, often I want to create a list at the other end. Rather than printing them, I want my new list, or I want an output list. So to do that, I'll start by making a variable before the for loop that contains an empty list. Let's call it my list equals such and such. So that just declares an empty list. And instead of printing Z, I want to have my list putting each Z number in there. So I'll say my list dot append Z. Now when I run this, like so, I can look at the output called my list. And you can see it has those numbers now being returned as a list. So this input list went in, was standardized to range between 0 and 1, and output a new list called my list, which contains numbers that range between 0 and 1. So it transformed the input using this. So that's one example of a for loop, of looping through a set of objects. But I'd probably want to have, before this, some checks, right? I want to make sure that X is in fact a list. So I might have a flow control here. I might say if type X is list, then undertake the following. So when I run that, and afterwards I'll just print this in here too as well. Say print my list, like so. So it just prints out the output. Well, that should actually be afterwards, because it looks weird printing each one out. So I'll just put that at the last line down here. There we go. That's what we want to see, just the output, the final output, not each step. And so that's using a flow control structure with a looping structure to produce some output. And the flow control here makes sure that X is a list, because what if X was a string? If we didn't have the if type X equals list here, and X happened to have been a string or something else, then the program would crash. So this is, again, just an example of if, then, and a for loop. So practice those. You'll need to be using a lot of them in the course. Okay, so for next week, you will read chapter 1, not chapter 1 to 4, but in the text that should say 3 and 4. Chapters 1 and 2 are just about IDEs and stuff. If you want more information about different IDEs, you can read those. And then you'll complete and hand in exercise 1. The deadline is 2:30 next week. Or I should say the week of the 18th, our second class. before the second class starts at 2:30. It'll be available for submission. So from the next step for you then is to, if you haven't already done so, is to go through the examples in the slides, try them out. Just reading them and thinking you understand them is very different from actually typing them out and asking yourself, how does the result I just achieved come from the statement I just wrote? You will not be successful in the course unless you actually practice a lot. And so you should go through all the examples in here, and then if you feel you need to, you might be familiar enough with Python that you don't need to do these basic examples on just the basics of Python. Depending on how comfortable you are, you may be able to go right to the exercise. Now, the exercises in this course are tightly bound with the lectures. So usually I give about an hour and a half to 2 hour lecture like this. And then the rest of the time, you work on the exercise, which is directly related to it. And many of the examples that you need for answering questions and exercises are in the slide material, and the rest of them are in the actual exercise examples. So they're shorter exercises for that reason, like in terms of the actual page length of the exercises. So not the exercises are not self-contained as in previous years. So they're half in the lectures and the examples in there, and half in the actual written part of the exercise itself. So they go together. There's also, you'll see in the exercise folder, there's Python for everyone. So if you want another quick review of the type of stuff we just went over, do the Python for everyone. Also in the Python for everyone, so the Python for everyone course by Esri, they show you how to set up PyCharm. So if you're working on your own computer, for example, your home computer, and you want to set up PyCharm, again, it's the most powerful editor for Python, IDE for Python. Well, that will show you how to set that up. It's very similar to what we did in what I showed in the example for PyScripter. So if you want a permanent IDE that you install that's directly linked to ArcGIS Pro's Python, you can find the instructions in the Python for everyone on that to do that. So you'll work on that stuff, and then you'll be able to undertake the exercise.